Hi friends! Due to development of alternative power generation, the voltage converters get widespread popularity. With them we can have the mains voltage from the battery and power any mains device outdoor. Our Chinese friends don't waste time and offer converters for every taste and pocket. Perhaps one of the cheapest options is a 12 volt to 220 or 380 volt converter board built on an CG3520 microcircuit. Of course, this isn't a completely finished converter and is sold as a board. In addition, there are many shortcomings. Firstly, the output AC voltage has a rather high frequency of 25 to 30 kHz and is different from a sinusoid. Therefore, I strongly advise not to connect any loads other than incandescent bulbs, soldering irons, and so on. Secondly, there is no stabilization, and depending on the input voltage and load power, the output voltage will walk in a wide range. There is no protection, neither from short circuit nor from high or low input voltage. During this video, we will create a similar voltage converter from 12 to 220 volts with an explanation of the principle of operation. And most importantly, we will partially modify this converter. So, stolen from the Chinese issue 5. You will find links to the previous issues in the description. We will make the output voltage of the converter constant and stable, which will allow connecting any mains consumers other than asynchronous motors and instruments which include an iron mains transformer. As you understand, our inverter will still lack protection against short circuits and battery discharge. In this case, the only protection against short circuits is the input fuse. But why did I call this inverter diamond? Most of the problems were related with fake Chinese transistors which burst under loads of more than 100 to 150 watts, but I will say more on that later. The board that will appear in the video is experimental. In the archive of the project, which can be downloaded in the description, you will find a normal, finalized board and you will not need to redo anything as I am in the video. And high-quality industrial boards can be ordered on the GLC website at the lowest prices. Production time is only 24 hours from the time of the order is received. The color, size, complexity of the boards isn't a problem because high-precision machine tools are used in the production and everything will be done at the best level. Just upload Gerber file of the board to the GLC website, select the options you need, and that's all. A link to the company's website and to the video with the full process of production of the boards can be found in the description under the video. To such converter, we can connect any kind of lighting, power adapters from modern electronics, computers, and other consumers. Our converter is stabilized and output is 220 volts with a slight deviation. If you haven't previously worked with impulse circuits or don't know much about electronics, it is highly recommended not to repeat this device, since here you will have to face the winding of a pulse transformer and you may need to adjust the circuit. At the output of the converter is high voltage. For many adjustment work, make sure that the circuit is disconnected and the high voltage capacitor at the output is discharged, despite the fact that a discharge resistor is connected in parallel with this capacitor. The value of some components on the circuit may differ from those on the printed circuit board, but this isn't critical and will work. The characteristics of the converter are as follows. Input voltage range from 10 to 14.5 to 15 volts, not recommended, apply more. Output voltage 220 volts constant, stabilized. Output power is about 300 watts and you can get up to 400, but not for a long time because the transformer will heat up. It is desirable to make the first connection through the limiting lamp to prevent the transistors from burning down in case of any error in the mounting. Let's go to the circuit and principle of operation. The voltage converter is based on the CG3525 PWM controller, which controls the powerful switches IRF3205. Due to the fact that this PWM chip has a powerful output cascade, there is no need to use additional repeaters to control the transistor switches, as in the case of the more popular TL494 chip. The voltage from the secondary winding of the power transformer is rectified and smoothed by the electrolytic capacitor. Stabilization of the output voltage is organized as follows. The CG3525 chip contains one error amplifier, which is used in the voltage feedback circuit. The non-inverting input of the error amplifier receives a reference voltage through the divider, which is formed by the internal reference source of the PWM chip. The inverted input of the error amplifier also receives a voltage from the reference source, only not directly but through the transistor of an optocoupler. The optocoupler LED is connected in series to the output of the converter through linear diodes and a trimming resistor. It works as follows. If the output capacitor voltage is more than 220 volts, then the linear diodes will open because in sum their stabilization voltage is 220 volts. I have slightly different linear diodes. Their total stabilization voltage is about 235 volts. In fairness, I will say that this resistor can regulate the output voltage only in a small range. As a result, the LED of the optocoupler will glow and the internal transistor will open. Via its transition to the first input of the error amplifier, the reference voltage is applied. That voltage is greater than the value at the other input of the error amplifier. In this case, the chip will reduce the duration of the pulses until the voltage on the output capacitor is reduced to 220 volts. If for some reason the output voltage drops below 220 volts, the PWM chip will increase the pulse duration until the voltage on the capacitor will come to the normal range. The longer the pulse duration, the longer the transistors will be open and the more current will be pumped to the transformer. The converter has a soft start system, that is, after power is applied, the output voltage doesn't appear instantly, but gradually increases. This capacitor is responsible for that effect. So that the microchip can fully discharge the capacity of the transistor's gates, the so-called dead time is introduced. This is necessary because the transistors must have time to completely close, otherwise they will overheat. After closing the upper transistors, there is a pause. At this time, all switch transistors are closed, and only after this small pause, the transistors of the lower shoulder will work. The duration of the dead time depends on the specified resistor. In the datasheet on the chip, you can see this dependency. Let's proceed to the power transformer. Its winding data depends on the operating frequency of the converter and the characteristics of your core. The calculation of the transformer is done according to specialized programs. My core is taken from a regular ATX 450 power supply. I boiled it in water so that the glue would weaken, disassemble core, wait until everything cooled down, and removed all the factory windings. The primary winding has 4+4 turns. It wound with the so-called Litz wire, that is, a bundle of a large number of parallel wires. Each wire has lacquer isolation. This is done to minimize the skin effect. Method used to increase the quality of the winding when working at high frequencies as well as for ease of winding. This wire is much more convenient to wound than the thick one. After winding, we put several layers of the isolation. I use a Kapton adhesive tape. Then we wind the secondary winding. My wire is 0.71 mm. Quantity of turns is about 120. Power transistors are installed on a common radiator, but remember, we must isolate them with heat-conducting pads and plastic bushings. Let's test our converter in action. We supply 12 volts to the input, and as we see, about 235 volts is at the output. Again, I remind you that my linear diodes are slightly different, hence the higher stabilization voltage. But it's not scary. Home appliances can be safely connected. Let's check the stability of the output voltage under the load. A 150-watt incandescent lamp will be as a load. As we see, the output voltage doesn't change. The stabilization works fine. The no-load current of the converter with a 12-volt supply is only 80 to 100 milliamperes. I often use fake transistors in homemade devices because during the adjustments and experiments we can burn any transistors, including the original. But the latter are expensive. Since everything risks being in the trash, you should not overpay for the original. They should be installed only after the circuit has been completely configured. So did I. Now in front of you the shots, where the converter just works with original transistors and a 300-watt incandescent lamp is connected to it. And then happened this. The exploded capacitor installed on the power supply circuit of the microchip, and it is completely incomprehensible why. It was installed correctly and had a voltage value margin of almost 3 times. There was no interference to the circuit because it was powered from the battery. The capacitor itself is good with low internal resistance. I have repeatedly used this and there were no problems. When there are no versions, even technical people become superstitious. I think about self-induction because at the primary circuit of the transformer wasn't installed RC circuit, but I did the same before, and sometimes it is not installed in factory inverters and everything works. Therefore, the version that the Chinese demons settled into the board is more truthful. I burned the original transistors because of my own carelessness. I done the short circuit at the output and then was puff. And I don't remember anything further. Only the fake IRF3205 remained, and I put in them after incident. Alas, now we can't get more than 200 watts. I have already tried. The transistors die instantly. Moreover, some transistors from the same batch are capable to give 200 watts, others don't. Well, let's finish on this. The printed circuit board can be downloaded along with the project archive by the link in the description. Please don't forget to rate the video, subscribe to my Instagram, and stay away from the Chinese demons. On this I say goodbye until next video. With you was Kaxiang TV.